Hello academics around the globe, welcome back to Caltex Academy. In case you're new, my name is Julius and thank you for coming around today. On our board we have a nice and beautiful question that is all about logarithm, and it says simplifying a half log of 16 to the base of 10 minus 2 log of c divided by 5 to the base of 10 plus log to the base of 10 of c squared. It's easy to tackle this kind of question. Now let's go on and we copy our question here saying we have 1/2 and this is multiplied by logarithm to the base of 10 of 16, and we subtract away twice log to the base of 10 of c over 5 and is added to log to the base of 10 of c, and this is square. How do you start tackling out this kind of question? Now it's easier than you think. What we need to know is all about the laws of logarithm. Now we're going to tackle them one by one as we continue simplifying. Our question here has 3 terms. So our first term is here, the second term is there, and the last term is here. So in our first term, there's a law of logarithm. Maybe I can cite it here, saying if you have a log, and this log is to the base of, let us say, a, and of course that log is, let's say, b, and we have here, maybe c. This is the same as we have our log to our same base, and the base is a. Now we have the logarithm, of course, of b. Now we'll simply raise up. What do we need to raise up? We raise up this c to go up as a power to the term b. So from here we can take our logarithm to b to the base power c, and that is the c that has moved up there. Our c is corresponding to 1/2, then our 10 is corresponding to a, 16 is corresponding to b. So applying this rule and make it here, raising up this as a power or an index, then we can go ahead and have this as logarithm to the base of 10, and we have our 16, and this 16 is raised to a power of 1/2. So from here, we're done with the first term. Now let us move on and we subtract our logarithm again to the base of 10, and the logarithm is of, this time is a fraction, so we have c over 5. Now we need to provide this one here in a bracket because there are 2 terms where these 2 will be an index of. Therefore, we can take that index 2 and place it there, and we are done with the second term. Let's move to the third term, and our third term is having positive here, so we add plus logarithm, and this is log to the base of 10, and here the number we have here is also c. Therefore, our c is squared. Now, the next thing we have to do here is let's handle addition separately before subtracting. Now let's recopy the first term here, at the same time writing this 16 in an index form, and we know that 16 is the same as, maybe let me put it here, 16 is the same as 2 to the power of 4. And if you are doubting this, you can go slowly and have it written here as 16. If you divide it by 2, what do you get? You get definitely 8. So 8 divided by 2, you get what? 4. And again 4 divided by 2, you get 2. Finally, the 2 divided by 2, you get 1. And from here, 16 will be the same as 2 to the power of the number times the 2 appears. So that is 4. So we're going to write the same thing here and say log to the base of 10, and we write this in the new form, and the form is 2 to the power of 4. And remember, this is raised to a new power, and our new power is 1/2. Let's bring this nearer because it is addition, since there's a rule that will connect it together, and we have log to the base of also 10, and the log is of c, and for uniformity, let us have this the same color, that is 2. Maybe we will also do the same thing here by taking these 2 out, and we have it in terms of the same color, that is a purple color too. Now let's move to the next one here, and that is the last term, and we have minus log, the same base of 10, and is of our fraction here. We can distribute this 2 to this number here, and we have c is raised to 2, and we divide it by 5. The power of 2 is the same as 25, and we move on. So we have to do the same thing we have done here. And where is that one coming from? Again, let us go ahead and state it here. If you have a logarithm, and this logarithm, the base of a of e, and this one is raised to another power, and you can say the power here is c, then the same thing is also raised to another power, we can say d, then this will be the same as our logarithm, the base of a, and the c as an exponent will multiply d, so shall have logarithm of b to the power of c and d, because c and d will have multiplied itself together as one number. So this one is already one number. So following this, we can move on and do the same thing here, where we have logarithm to the base of 10, and when we take a look at our number here, 4 times 1/2 is the same as we reduce this by 2, and shall have only to the power of 2. Therefore, this one will, okay, maybe we have to show it here saying 4, and this 4 is multiplying 1/2. Then we can reduce it for us to be able to see clearly by 2, 1. 4 divided by 2 is 2. Now we move to the next term. This one remains the same. You first need to simplify the first term before combining them together. So we have logarithm to the base of 10 and of the number c exponent 2. So here the next one is already simplified, so we need to copy it here. So there are two rules that we can apply here. You can decide to apply them once, or you can divide them. I think for me it's good to apply them separately, such that each one of us will understand exactly why it happens. So at first we need to simplify this such that it's clear before applying our rule, such that we clear this mess up. Now this is the same as 2, and here this has reduced to an exponent of only 2. Now we can move on and have this addition. This is to the base of 10, and remember, for base 10 you can decide not to write, is totally accepted, because by default all our calculators are to the base of 10. This is to the exponent of 2, and again we are subtracting away logarithm to the base of 10 and c over 25, and it's also squared. Now let's move on and apply our first rule, and this rule is of addition. We can put it here. If you have logarithm to the base of maybe 10 of a, and you are adding this logarithm to the base of 10 of b, this can be combined to one logarithm to the base of 10, and since you are adding, we multiply the two numbers together, then it becomes a, b as a single number. So applying this rule here, we'll have the same as logarithm to the base of 10, and we have, maybe we can create a bracket here, okay, and our two numbers are 2 exponent 2, and since we are adding, remember here we'll be doing what? We'll be multiplying. Let me hope we are all together up to this time, and we multiply by this one here, that is c also exponent 2, and we attach our next logarithm here, minus logarithm to the base of 10 of c squared. Therefore, let's keep simplifying our work. So we have the logarithm. Now this time we need to bring in also a certain rule. Now this rule, I can also put it around here, saying if you have logarithm of a number a to the base of 10, could be any base, so long the bases are the same. And this time we're subtracting logarithm of b to the base of 10. What we can do is we can maintain the same logarithm to the same base, but then we will be dividing the numbers a divided by the second number b. And if I've just used the sign a divided by b, it doesn't matter, the meaning is the same. So since we're subtracting, meaning we need to divide here. So this is to the base of 10, and let's get more space, and therefore our bracket will be somehow expanded because there are two terms we need to input here. So the first term is our 2 to the power of 2, and we multiply this by c, and our c is also to the power of 2. Then we're going to divide this by that. So here we say divide by, this one happens to be a fraction, so we have c squared over 25. So let's put our exponent in the same color like that. So let's have that. Now we're left with the task of reducing it down. We can move on and reduce this to a single number. Of course, 2 exponent 2 is 4. So let's move on and continue simplifying, saying we have a logarithm to the base of 10, and we have here the numbers from the numerator has reduced down to 4 times c, and this is squared, so we're going to divide this by our c squared also. But remember, we're going to take the 25 up to multiply this number. We have there times 25. Now after this stage here, we'll see what will divide or what will multiply in order for us to find out the simplest form here. Now you can see here that, okay, c to the power of 2 will cancel with this c to the power of 2. And again, I'm seeing some good news here that this multiplies to 100. Therefore, we need to have our logarithm to the base of 10, and this logarithm has simplified itself to 100. So the number is 100 to the base of 10, and we also know that 100 can be written the same as 10 exponent 2. So let's move on and do that. Therefore, our logarithm to the base of 10 to the power of 2. We'll have to apply the rule we made earlier on, where we raise the power up. This time we're going to lower this power down, and say this is equivalent to our 2, which has been lowered down, and this multiplies the logarithm. You can decide to write the multiplication sign or just simply close it up with our word logarithm, and we have that. And what is this? 10 left here. We also have another sweet rule that says if you have a logarithm of, say, a to the base of a, this one will vanish down to 1. Now if that is the case, take a look at what we have here. It's logarithm of 10 to the base of 10. And since the logarithm and its base is the same, it vanishes to 1. Now because of that, we have a reason to smile. Therefore, we have here 2, and this multiplies 1. Now finally, when we multiply 2 times 1, our answer becomes what? 2. And that answers our question. I've just simply gone slowly for a purpose such that at least everybody understands well if you used to struggle with logarithm. And that is how beautiful logarithm can be. And please, before you pen off, you can also subscribe to the channel to get notification for my upcoming video. See you in the next one. Peace out.